Hello guys. Welcome to today's session. I hope you're all doing well. Am I audible? Can you all hear me? All right. So, in today's session, so we're continuing from object orientation programming classes. So we're going to be doing composition. Composition in simple terms, it's a class inside of another class. Right. So I already have everything set up. So for today's practical, we're going to have ujimage.cpp, main.cpp, flag illustrator.cpp source files, and that's my bash file over there. I'm quite sure you already know how to run a bash file. So this is my bash file. As you can see, nothing new from there. So yeah, these are the files which we are going to be working with today. So what we're going to do now? So we're going to have a UJ image. So you know your UJ image is going to have the 2D array of RGB color. So for today's practical, so my UJ image is going to be drawing flags. So we're going to be drawing 3 flags, and a Japan flag, a Nigerian flag, and a France flag. Okay, so that will be what my UJ image will be doing, and obviously it's going to have all the other member variables and functions, like getters and setters, rows and columns, and whatever. And as for the flag illustrator, so my flag illustrator is going to contain our UJ image, and obviously it's going to manage the life cycle of UJ image. So uh we're going to have a function called illustrate flag, which we're going to pass a flag. So a flag is either it's Japan, Nigeria, or Algeria. So this is an enumeration. So we're going to pass it, then it will draw that certain flag which we passed. All right, and what else? Obviously, the 2ppm. Obviously, this function, this class flag illustrator is not going. It's not going to be doing the job. It's going to delegate the job to the UJ image, which we're going to add in our class. So, anyways, let's start. So we have our module here. It's called UJ module, and our namespace is called UJ space. So we're going to start with implementing our class UJ emoji. All right. So I also want to like create the UML diagrams for today's lesson, because so just for you to understand how we draw the UML diagram. Oh, I actually don't have the here. Let me open draw.io. Okay, we'll come back to that while it's opening. So for our UJ emoji, so we have our 2D array, RGB color, penta. We have our 2D array. I'm gonna name it grid. We have our rows and columns. The usual. Then we have our background color, RGB color, BG color. And what else? And you have our constructors. So This is the constructor without parameters, which is the default constructor. The constructor with parameters, we're going to pass in the rows. Let me do capital letter rows. Actually, no, let's do proper things. Just small letters. Int rows, int calls, and a background color, RGB color, background color. And we're gonna have the copy constructor. We're going to pass in our image object. It passes by reference object. And we're gonna have the deconstructor. Okay. We're going to have our clone function. So void clone. Let me copy this out. This one you can pass it by a constant, but I'm not gonna pass it by a constant due to that. Then we have a function to allocate memory. I'm just gonna call it allog memo. Don't need to pass anything. Then we're gonna have allog memo. I'm not gonna pass anything. Sorry. Oh, not us. We're gonna have a function to draw a circle. So we're going to need. Yeah. You can speak a little.
Evening, everyone. I am looking at the clone function. So the reason would have, okay, I just noticed something today. The reason we are having the clone function is because when we are copying, right, if I use the allog memo function, they will point in the same address.
They will point in the same address.
Yeah. If let's say I'm using the copy constructor, right? Then I allocate memory for that copied object using the allog memo function. So what I want to know is when I do that, I'm basically pointing at the same memory.
And not
That's why we need to
really.
clone it. Okay.
Not really. So what you'll be doing, or actually let me, for my function to allocate memory, let me actually pass this thing. So in our copy constructor, so we're going to start by firstly allocating memory for our object, for this object. Okay, so we're going to allocate memory using the data from this object you are passing here in our copy constructor.
Yes.
So using its rows and the columns and the background color.
Okay.
Then afterwards, we're going to use this function, clone function, to copy the whole grid to our grid.
Oh, okay.
Yes.
I'll show you my code after. I'll show you. You can continue. Okay.
Okay. So let's continue. So we have a draw cycle. So we're going to have the center row, the center column, the radius, and the color of our circle. So if you want to draw a circle, you have to have the function to calculate distance. So it's going to return double. Yeah, it's going to return a double. Let me call it this distance. So we're going to pass in x1, x2, let me just do small letters, x1, x2, y1, y2. Then we're gonna need a function to draw, rectangles and squares. So we're just gonna create one function to draw a quad. A quad is it's a shape with four sides. So yeah, so for our flags, we're gonna need a function to draw a quad. So okay, so let's have a function to draw a quad. Draw quad. So you don't really need to memorize these functions. So this is just an example for our practical today. So don't stress. So for our card, we need to pass in. We're going to pass in an x, and we're going to pass in a height. So this is the starting row. X is the starting row. I'm just going to name it x. Then we're gonna have the height. Then we're gonna have the starting column. I'm just gonna name it y. Then we're gonna have I don't know how to pronounce this. I have a gap. The what if and we're gonna have the color for our card. So color. So yeah, so this is the starting row. X is the starting row and Y is the starting color. Then we have the height and we have the width. Obviously, if you want to draw a square, height height and width has to be the same. Then if you want to draw a rectangle, obviously I think the width is the one that's going to be longer, but they must not be equal. So I think you know that. And to draw a circle, so just like how to draw a circle, we need a distance function. So to draw a quad, we also need a function to check if we're within if we're to check if we're within a square or a quad. So I'm gonna make it a bool function. I'm gonna call it is in range. Is in range. Okay. Then we're going to have our starting row, and we're going to have let's have R. So we're going to this R is for again we're going to loop through our grid. So I'm going to have our R, I'm going to have our X, I'm going to have our height. Then we're going to have our C, then we're going to have our Y, and we're going to have our I don't know how to pronounce it, width. Okay. And what else? I think that's fine. So for public functions, obviously, you have to have the setters and getters for all of these, not all of them for these. So let's create a to ppm function string to ppm. Also gonna need that, and also gonna need getters and setters for our data. So let's have int get rows, then void set rows. Then I'm gonna pass in the rows. So int rows. Then I'm gonna have int get calls. Then void set calls. So if there's a question and you post it in the chat, raise your hand so I can go inside the chat and check the question because I can't see it. Void set calls and what else? So I'm gonna have RGB color. Let's have get pixel. We're gonna send in a row and a column. Okay. And also gonna have set pixel. Gonna send in, gonna pass in the row and the column and the color. And we're gonna have RGB color, get background color, and we're gonna have void set background color. Then I'm gonna pass in a background color. Okay. I think that's enough. So we're also gonna have, so I've already created my enumeration over here. So code flag. So we're going to have, let me do it here. We're going to have a function to draw the flags. So I'm just gonna make it a void function. I'm gonna name it draw flag. Then I'm gonna pass in our flag. Yeah, you can ask your question. Uh,
Okay, so my question is, could you please explain why the functions for drawing the shapes are now private instead of public? Is it because we're gonna place them in another class?
so so the reason why they're private is because I'm going to have, you see this function draw flag. So we're gonna use this function. So when we call it, we're going to pass in a flag which we want to draw. And let's say we pass in Japan. So Japan, remember Japan is just we just draw a red circle with a white background. So in this function, I'm just gonna call in those that draw circle function. So that's really the main reason. So we only need a draw flag, and draw circle and draw quad are really just helper functions for this example. So yeah, I would say the main practical for today is just to our UJ image to draw flags. So we have, that's why we have our function here to draw flag. So we pass in the type of flag you want to draw, then we draw it. So this function draw circle and draw quad are really our helper functions to draw those circles. So they don't need to be public. I'm not sure if that's clear. Alitan.
The flag is a class, no? The flag keyword, the one that's light blue.
No, it's an enumeration.
It's an
So
enumeration.
we have
Oh,
Japan,
it's
we have
an
Nigeria, and
okay,
we,
okay.
let me
Okay,
change
thank you.
this. So we have Japan, Nigeria, and we have France. Let me change this one. So
Oh,
yeah,
okay, thank you. Okay, okay.
so in our draw, we just pass in that. We just pass in the type of flag we want to draw, then we draw it. Yes, I want that.
Okay, greetings everybody. Okay, now ask you pertaining the namespace. Auntie, isn't the class similar to the namespace?
I can't really hear what you're saying.
The like in this case, we are having both the class inside the namespace.
Class, yeah, this class is at our namespace. So this is our namespace, UJ space, and this is my
Isn't
ex. Yeah,
isn't it like almost the same thing?
is it not? Oh, you are saying, is it not the same thing?
Yeah, like They were like we will no longer be using the namespace.
I didn't get that. Can you like type it? Cause I don't know if it's your mic or what. It's low. So mm, are you typing the question? So could you please explain why the functions for drawing the shapes are not private instead of public? Is it because we're gonna place this in another class? No, not really. So as he's typing, let me try to explain these things of shapes. So like actually, I'm gonna use a very simple example. Uh, when you got a microwave, so when you have a microwave, they say this is a microwave and it has this type of functions. So let's say one of those functionalities is to heat food, for example. So obviously, so when you have an object, a microwave of type microwave, so you only have access to that function called heat food. So obviously, heat food inside of it uses other helper functions. We don't know them. It uses helper functions. So we don't need to. We only need to call that function heat food. We don't need to know what's going inside. How is the functionality? I want to say accomplished. Yeah, how is the functionality accomplished? So the function itself can use other functions, but then we don't need to know all about those functions. We don't need to have access to those helper functions. So in our case, in our practical, uh, our UJ image draw flags. So our draw flag function uses other functions, helper functions, and those helper functions are your draw circle, your distance, and draw quad, and is in range. We only need to have access to draw circle. We just need to pass in the type of circle, the type of flag we want to draw, and the draw circle function will use those functions to draw the required flag. So that's why these are private. So this is like this is called information hiding. So we don't need to know how something is done. Like we just need to we just need to do the function, but we don't need to know how that thing does that functionality. So that's the main reason why those are private. And only draw flag is only public, because those are helper functions. Those draw cycle, those are helper functions. They help draw flag to do its work. So we don't need to access those functions. So that's why. I'm asking if it's possible to have the class inside the namespace. Aren't the namespace and class similar? No, 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 no. I'm asking if it's possible to have the class inside the namespace. If it's possible to have a class inside the namespace. I think the namespace and class similar. No, they're not similar, and our namespace does contain our class. So this is the start of our namespace. So namespace UJ space. Then actually we have our export there. So inside our namespace, we have our class and our record structure and our enumeration, and we have our class. So namespace and class are not the same thing. They're not the same thing. So this is how we do it. Is that clear? I don't really get your question, but yeah, they're not the same thing. Mm-mm. And yeah, our class it is within our namespace, as you can see. So this is where our namespace scope ends here. then our class is inside. So that's our class is here inside. Is that clear? So we can move. So these are all the functions we're going to need. So let me create my UML diagram looking at this class before I implement them. Okay. So I don't have D here, so I'm going to use what's this? I'm going to use draw.io. Oh. I'm gonna use draw.io. It's the same as D, but this is just an online thingy. So so this is our class. Let me use this one. So this is our class thingy. So we're going to write the name of our class here. Let me do this. Let me put it this side. So yeah, we have our class name. So the name of our class is UJ image. What's that thing? So we have UJ image. Then then we have our private member variables. So we have so these are private. So remember, if something is private, we need to specify it using this minus sign, subtraction sign, whatever, or a dash. Yeah, this is a dash. So we have a grid. This is the 2D array of RGB. So I'm gonna write the type. So this is RGB color, pointer. Let me add some few. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 10. Then for our public functions, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Obviously, I'm not gonna do all of them, so I'm just showing an example. 5, 6, 7, 8, 9, 10. Let me just end it there. So yeah, so we have our variables there. We have the rows. Then we specify the name type. Then we have the calls. Then specify the name type. Then we have our functions. So let's try clone. So we have a function clone, which accepts some parameters. So it only accepts a UJ object, UJ emoji object. So we're gonna say object, then the type after the column. So it's UJ emoji, and this is a void function. Doesn't return anything. Let me do that. Then let's add the last one. So we have draw cycle. That's actually long. We have draw circle. Then I'm gonna pass in our parameters. We have CR, then of type int. Then we have CC of type int. Then we have radius of type int. Then we have background color of type RGB color. Okay. GB color. And our function, it's a void function. So yeah, so let me cancel this one out. So obviously you have to add everything. So I'm just gonna add this few. You have to know that you have to add everything here. Then, so let me add maybe let me add one constructor just for example purposes. So that's public. So we have our let's do the constructor with parameters. So we have a constructor with parameters, and it passes parameters rows, which is an integer, and it also passes calls, which is an integer, and also pass background color, which is an RGB color, and it does not return anything. So you don't have to doesn't have a return type, so you don't have to write anything. Then let's add one more function to ppm. So to ppm, it does not have any parameters. Then it's a string returning type function. So let me cancel out the rest. The rest of these columns. Obviously, we don't have time to fill everything out here. So this is our class. So this class obviously have to contain everything you see here. So I don't have time to add everything, otherwise we won't finish. But then that's fine. So let's implement these functions. Let's start off with our clone functions. I'm gonna implement them here. So remember, if you want, you can implement them outside and implement them here, but I'm just gonna implement them right here in the within the class definition or implementation. Okay. So for our clone function, what we're gonna do, we're just going to loop through our grid. So we have int r is equals to 0, r is less than rows, and r plus plus. And you have int c is equals to 0, c is less than equals, then c plus plus. Okay, then yeah, so what we're gonna do, so we're going to copy everything from this object's grid, then copy to our grid. So we're gonna it's going to be equals to, we're going to access this object's grid. So this is object dot grid at r and c. So this is what the clone function is for. We're just copying the grid from this existing object to our grid. So this is our grid. Then we copy everything from this grid that belongs to this object, then copy it to our grid. So that's the main purpose of our clone function. Anyway, I'm gonna add a function here called fill. So I'm gonna pass in a color. So what fills? So this function, I'm just gonna use it to fill the whole grid with a specified color here. So let me copy out this for loop here. So I'm gonna set everything to color, the whole grid to color. So this is just my helper function. So I'm gonna use it. Then we have allocate memory. So we have allocate memory. So in our allocate memory, first of all, so we're going to initialize our data. So remember, this is our data. So I'm going to initialize our data to this data I just passed here. So you notice that the name of our parameters are the same as the name of our data in our class. So if I try to do this, if I try to say rows is equals to rows, so I'm trying to say these rows as this one is the data in our class, and this rows is the one from our parameter. So this is this is not possible. So I think we spoke about this in our last session. So this is going to cause something called some sort of ambiguity. I forgot what this error is called. So what the compiler will do. So since this parameter rows is this has the same name as this data rows. So what the compiler is going to do, the compiler is going to only focus on, it's going to only take this one in the parameter. So here, when you say rows is equals to rows, you're basically calling this one. So you're actually equating a variable to itself. So what do you do if you want to tell the compiler you are referring to these rows? So here the compiler is going to get confused. Which rows are you talking about? Because there are two rows. There's this one in the parameter, this one in the data in our class. So which one are you talking about? So in order to tell the compiler which rows you are talking about, if you leave it like this, the compiler is going to what's the word? So it's going to think you are referring to this one. So, but what if you want to refer to this one? You're going to use this keyword. So you're going to say this pointer rows. So what this does is going to tell the compiler that we are referring to these rows, this data variable rows within our class. And this one is going to take it as it is this one passed in the parameter. So yeah, this is going to be a question in your semester test one. I forgot the name of this error. Alitan, can you type in the name of the error in the chat? Anyway, let's continue. Then we have calls. Then we're going to also set the background color. So this background color is equals to background color. Background color goes to background color. Then we're going to allocate memory. We have grid is equals to new RGB color. Pointer is going to be rows. So remember, it doesn't matter because either is this one in the class or is this one that the same, so it doesn't matter. So let's continue. So int r is equals to 0, r is less than rows, then r plus plus. Okay, we're just gonna allocate memory. So grid at r is equals to new RGB color, and it's going to be size of course. Anyway, at the end, I'm gonna use this function fill. So I'm gonna say fill, then I'm gonna fill my grid to the background color. Okay. So that's how my function to allocate memory. So far so good, né? Overshadowing or name overshadowing. Let me copy this. So yeah, the error here is called overshadowing. So they're going to ask you, what is this? And how do you solve it? You're not gonna say this is how you solve it. So they're going to ask you this. Then to deallocate memory, so we have int r is equals to 0, r is less than rows, r plus plus. So we're going to delete and grid at r. Then I'm going to delete the whole grid afterward. Delete grid. Yeah, that's our function. Then we have a function to draw a circle. So for the function to draw a circle, Okay, so we need to use this function distance. So we're going to look through our grid. So let me copy and paste my for loop over here. It's my for loop. So I'm going to check if the distance between R and the center row and C and the center column. So we're going to calculate the distance and we're going to check if the distance is less than or equals to the radius. If that's the case, then we're going to fill in our color there. So we're going to say grid at R and at C is equals to color. Okay. Then for function to calculate the distance, I remember this is the is it theorem of Pythagoras or what is that? Yeah, so I have my CMF library included there. So you know the function to calculate the distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. So this is the function we're going to write over here. So return. So this is going to be the square root of. So we have power. We have x1 minus x2 the power of 2 plus plus y1 minus y2 to the power of 2. So you're going to notice here I used my square root function and my power function. So the power function just, so this is the base. So here we pass the base and here we pass the, what's that? The power. Yeah, so 2 is the power. So this is going to be x1 minus x2 to the power of 2, as well as this one. Then it's going to be under a square root. So you know, in order to use this square root function and this power function, you have to include this header library CMath. Yeah. Then we're going to draw our quad. So same, we're going to look through our grid. Then we're going to check if we are within range. So this is my in range function. So it returns a boolean. So if we're within range, so here we're going to pass in our R, and we're going to pass in what's after our X. This is our starting row. Then we're going to pass in our height. We're going to pass in our our C. Then we're going to pass in our starting row, starting column, which is Y. Then we're going to pass finally our width. So if we're within range, so this is going to return true. Then if it returns true, then we paint our grid. So yeah, so let's implement this function is in range. So for this function is in range, int r, int x, height, c, y value. So we're just going to check if, let me do it. So we have a couple of conditions to check actually. Let me do it like this. So let me return true over here. Then at the end, going to return false. So this is actually like this. So I'm going to have, we're going to have more than one condition to check. So firstly, we're going to check if R is greater than or equals to X, and we're going to check if R is less than x plus height. And we're going to check if y is, c is greater than or equals to y. Then finally, we're going to check if c is less than y plus the width. Yeah, this is the whole function to check if we're within range. So we're going to use this function to draw our quad. Okay. And yeah, let's move on to our constructors. So we have the default constructor. So here we're just going to use constructor chaining. So we're going to call in the constructor with parameters. Then we're going to pass in some default values. Remember, you can declare those the default values as constants over here. So I'm not going to do that. So we're going to pass in 500, 500. So these are the rows and the columns. Then for our background color, let's just give it a random color 128 and 200, then 99. I don't know what the color is, so this is just a random color. So this is constructor chaining. Then for our constructor with parameters, we're going to call our function to allocate memory. So allocate memo, we're going to pass in the rows, columns, and the background color. Then for our copy constructor, firstly, we're going to allocate memory. So remember, we're going to allocate memory using the data of this object we just passed. So object dot rows, object dot calls, then object dot background color. Then afterwards, we're going to call the clone function. So clone, I'm just going to pass in our object. Okay. Then for our deconstructor, just going to delete, deallocate our memory. Okay. Then we have our function to ppm. Let me actually move fast. So to ppm, we have a string stream ss. Remember, we have to have the stream library. Let me check. So there is it. And yeah, so we have ss. Then we're gonna pass in p3 or p2 and line. Then we have the columns, space, and rows, and line, then 255 and line. Then I'm going to loop through our grid. Let me paste my for each loop. Oh no, this is a nested for loop. Then I want to say ss and grid at r, and let's see dot red space grid at r, and let's see dot green space grid at r, let's see dot blue space, and here we have ss and line. So going to return our ss at the end. So return, remember ss is a string stream, so we need to convert it to a string. So we're gonna use the str function. So we're gonna say ss.string, which is going to convert ss to a string, because ss is a string stream, not a string. So to use this function to convert it to a string. So to use this function, you need to include the header library string, as you can see over there. Okay. Let's move on to, we have a lot of functions. Hey, let me leave out this one for last. Let's start with our getters and setters. So we have get rows. So it's gonna return the rows. Then we have set calls. So this is going to be this rows goes to rows because the name are the same. Then we have get calls. So this is going to be return calls. Then you have set calls. We have to pass the calls. This is going to be this calls goes to calls. And we have get pixels or return greet at R NFC. This is taking all of our time. Then we have set pixel. So this is going to be greet at R. Let's see, it's equals to color. Then we have get background color. So just gonna return the background color. Then we have set background color. This is gonna be this background color equals to background color. Then for our function to draw a circle, so remember we're going to pass in the type of circle we want to draw. So here you can choose to make a switch statement or an else if statement. So let's just have an else if statements. So we're gonna say if flag is equals to, let's say, Japan. So remember this is our enumeration. So Japan. So we have Japan, we have Nigeria, we have France. So this is just our enum. Okay. So here we're gonna draw the Japan flag onto the grid. Then we have else if flag is equals to let's say we have Nigeria, and we have else if the flag is equals to France. Okay, so yeah, to draw the Japan flag, the background has to be white. So I'm gonna use that function fill to fill my background, everything to white. So I'm gonna pass in my color here. So remember, white is 255, 255, 255. That's my color. So remember, fill just accepts a color. Where is it? Yeah, we implemented here. We just accept a color and we fill in our grid with that color. So that's why I have that function fill. Then we're also gonna draw a circle. So we have draw circle. So we have to pass in the center row and the center column. So for the center row and the center column, let's just divide our rows by 2 to draw the circle at the center. Columns divided by 2. Then we have the radius. Let's make it 200. And we have the color. So the color of our circle is red. So this is going to be 25500. Okay. Then for Nigeria. So remember, Nigeria it's green, white, green. So we're just gonna draw some rectangles. So firstly, let me make the background color to white as well. To avoid drawing three rectangles. So the first rectangle is actually green. So let me draw it using my draw quad. Which are going to pass in the center. I mean the starting row. So this is gonna be 0. And let me check that function. Draw card, then we have the height. So the height is going to be the same as the rows. So rows. Then for the starting column, we're gonna have 0 as well. Then what else? Then for the what's this thing? For the width, we're gonna say equals divide by 3. Okay, then we're gonna pass in the color, which is green. So we're gonna have 0. So this is like a light green. So we're gonna have 0, 135, and 81. So this is the first rectangle. Then in the middle is white. You don't need to draw a white rectangle because I already filled everything with white. So I don't need to do that. Then we're gonna draw the last rectangle, which is also green. So here, the starting row is still going to be 0, and the height is still rows, and the starting column is going to be, let's make it 2 times cos divided by 3. So yeah, you didn't need to understand this. This is the height. Then we have the starting column still cos divided by 3. I mean this is the values. Then we have the green color as well. Then for France, so France has like a blue stripe, and I think it has a white stripe in the middle. Yeah, and also a red stripe. So let's start by filling this with white also. Then I'm going to draw. Let me copy this. Draw quad. So the starting column is going to be 0. Then rows. Then cos divided by 3. Cos divided by 3. Then we have 0 rows cos. I think I'm missing something. So this will be 0. Then this will be cos divided by 3. Then the color is going to be 85. It's going to be 164. Okay, this is the first blue stripe. Then in the middle, we don't need the white stripe because we already filled everywhere with white. And then we have the final stripe, which is the red one. Yeah, you can ask the question.
Why is it cos divided by 3 and not rows divided by 3?
So yeah, this is the starting column. So we are going to begin. I will begin drawing our rectangle at the starting row and at the starting column. So this is why this is. Remember, we're dividing. We have 3 stripes. So I want to divide this into 3 sections. So that's why this is cos divided by 3 and not rows. If it was
Okay.
rows, it's going to be vertical.
No, I understand you, but remember that the flag of Nigeria, the stripes are vertical, and in the flag of France, the stripes are horizontal. So shouldn't what you did for Nigeria be the opposite of what you do for France now? So meaning since you had cos divided by 3, for Nigeria, you should then have rows divided by 3 for France, since the stripes are oppositely structured.
Okay, let me check it.
Oh, okay, no, I'm wrong. Okay, I hear you now.
Thought I was tracking. Okay, let's continue. So then, yeah, we're going to draw the final stripe, the red one. So this is going to be 0 rows, 0. No, this is not going to be 0. This is going to be. It is going to be the same thing. This is going to be 2 times cos divided by 3. Then we have 23965. Then we have 53. Okay, so let's compile our code and check if our UJ image is proper. Let's check for errors and correct them if they're there. Okay, so we have some few errors. No matching function for call to UJ image space. Blah, 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 blah. Draw flag 0. So draw flag is 0. So this is in UJ emoji. Okay. So no matching function for call. So this is line 190. Draw flag. Mm, 190, 190, 190. So I was supposed to be saying draw quad, and I was busy saying draw flag. Draw quad. Damn it. Draw quad. Let's check if there are any other errors besides that. Okay, there are no errors. So our UJ emoji is now 100%. So any question before we head over to Flag Illustrator? Any question? Why are we dividing by 2? I didn't get that. So yeah, we're dividing by 2 because we're trying to draw, we're dividing the flag into 3 sections. That's why we're dividing by 3. So here you know the 3 stripes there. So for example, green, white, green. So that's why I'm dividing by 3, because I want to draw 3 rectangles on for my flag on my grid. Any questions besides that? So it means if there are no questions, it means we're on the same track. So yeah, remember this module for my UJ emoji is called UJ space. I mean UJ module, and the namespace is UJ space. So in my Flag Illustrator, I'm going to import my UJ module and my UJ space. Obviously, if I don't do that, the errors, I'm going to have errors. So I have to import those module and my namespace. Then for my Flag Illustrator, I'm going to create it and put it under a module called Flag Illustrator module. And the namespace, I'm going to call it Flag Illustrator space. Then we have our class here. I'm going to call it Flag Illustrator. So let me do this. So let's add our class over here. our Flag Illustrator class for this class. So we have Flag Illustrator. Flag Illustrator. Let me delete this. And I'm gonna start from there. Let me just do that for now. Let me leave some few dots there. So I'm gonna fill this out right now. So for our Flag Illustrator, so remember we're doing composition. So our Flag Illustrator, we're going to have a variable, an object UJ image inside our Flag Illustrator. So let's start from there. So we're going to have our UJ emoji. So remember this is a pointer. So this has to be a pointer. Okay. So we're going to store this as a pointer. So remember we have memory management. So like composition, like you're storing a class inside of another class. So in this instance, a Flag Illustrator is going to have an object of type UJ emoji. Then we have to, Flag Illustrator has to manage the life cycle of this UJ emoji object. So we're going to call it, let's just call it, I don't know why I'm calling it UJ emoji, but then that's fine. Maybe I should have called it something like flag or something, but then it's fine. Let's just call it emoji. So we have our emoji right there. Then we have our, we're going to have our constructors. So we have the default constructor, the constructor with parameters. So the constructor with parameters, we're going to pass in the rows, columns, the background color. Then we're gonna have copy constructor, so Flag Illustrator, a reference. Let me just call it object to make things simple. Then we have our deconstructor. And we're gonna have two functions. We're gonna have a to ppm function, so string to ppm. Then we're gonna have illustrate flag. So I'm gonna make it a void function. You write the correct spelling. So illustrate. Then here we're gonna pass in our enumeration. So flag is going to be flag. Then yeah, that's it. That's it for our Flag Illustrator. So let's create our thingy. Before we implement those functions, let's add this thing to our what's this? Our UML diagram. So we have our emoji of type UJ emoji. This is a pointer. We only have that. Then we have our constructors. So for this one, I might as well add everything. So we have 1, 2, 3, 4 to ppm and illustrate flag. Oh, sorry. So we have our default constructor. Doesn't have any parameters. Then we have our copy constructor, which have these following parameters: rows, which is an int. Then we have cores, which is an int. Then we have background color, which is an RGB color. And let me expand this thing. Then yeah, this is our constructor. It doesn't have a return type. Then finally, we have our copy constructor. The parameters, we have an object parameter of type Flag Illustrator. Then our final constructor, we have our D constructor, doesn't accept anything, it doesn't have a type. Then we have our 2ppm. Our 2ppm, it's a string returning function. Then we have illustrate. Illustrate. It has a flag parameter which of type flag, and it's a void function. So now, yeah, we have two classes here. So the relationship between our two classes is composition. UJ emoji, it's inside of Flag Illustrator. So Flag Illustrator handles the life cycle of UJ emoji. So we have to show the relationship. So this is composition. So composition is shown by that diamond thingy. Let me look for it. Yeah, this one. Apparently, there's a difference between the shaded one and the other one that's not shaded. So yeah, so you see the names are appearing there. So if it's not shaded, it's aggregation, and if it's like there are two types of composition actually. I can't recall them right now. I think it's something like association and like an aggregation. So both of them still is the class inside of another class. But for aggregation, I think this occurs if, so you see we have UJ emoji inside of Flag Illustrator. So let's say if Flag Illustrator, let's say maybe UJ emoji can exist without Flag Illustrator, that's going to be aggregation. Like for example, so this is going to be in your semester test one. Let me look for proper examples. Association and aggregation. So anyway, but we're not in a rush, so I can't think of any examples right now. But then in the next session, we're gonna have a session where we're doing semester test one. So I'll come up with those examples on the difference between aggregation and association. So UJ emojis contained in the Flag Illustrator. So this should be, it's going to look like this. So this shaded diamond is going to point to Flag Illustrator because UJ emoji is inside Flag Illustrator. So that's why this thing is going to point to the Flag Illustrator. So this is composition. Yeah. Any question? Any question? This is how the UML should look like. Yeah, obviously you have enumeration and record structures. You add them there. So anyway, so for our what's this? For our default constructor, let's use constructor chaining and call in the constructor with parameters. So we're gonna pass in the rows. So obviously, as I said, you have to create constants for this default values. I'm just gonna explicitly type them out here. Then for the background color, let me just add a random color. I don't know what color is that. Then for our constructor with parameters. So remember we have a pointer here. So we need to allocate memory for this pointer. So we're gonna say emoji is equals to new UJ emoji. So yeah, so emoji is equals to new UJ emoji. Then we're going to pass in our parameters. So remember, if we leave it like this, actually this is wrong. So here for our default constructor, we're just going to allocate memory for our UJ emoji. Remember, if we leave it like this, we're going to create our object emoji using the default values. Remember, in our UJ image, we have our default constructor. So these values are going to be, so these default values are going to be used instead. So if we leave it like this, so if you leave it like this, we're physically calling the default constructor of UJ emoji, which is this one. We don't need to pass anything. Then for this one, we're basically calling the constructor with parameters of UJ emoji. So it's, you can clearly see this is a constructor with parameters. So we're gonna pass in the rows, the columns, and the background color. So yeah, obviously emoji has a grid, rows, and columns. So they're going to be set to this one. So going to be the rows are going to be set to these rows are passing, these columns are passing, in the background color is going to be set to this background color we're passing. This is our object. This is what we do. Then for our copy constructor, so for a copy constructor, so we already have a copy constructor from our UJ emoji. So instead of creating our own functions here, we're just gonna call this copy constructor. Actually don't know how to call it. So this is going to be emoji is called to new UJ emoji. Then I'm going to pass in our original object. So by doing this, we're calling the copy constructor of UJ image, this one. So obviously it's going to handle the allocation and the cloning. So no need for us to stress. Then finally we have the deconstructor. So in our deconstructor, remember Flag Illustrator is managing the life cycle of a UJ image from the beginning, from birth and to the end. So here at the end in our deconstructor, we have to delete our emoji, our UJ emoji. So this is gonna be delete emoji. So yeah, this is life cycle management. As you can see, if Flag Illustrator is handling. So when Flag Illustrator dies, this thing, the UJ emoji also dies. So yeah, this is basically composition. So without Flag Illustrator, UJ emoji does not exist. So if there was a case where Flag Illustrator doesn't handle the life cycle of UJ emoji, then that was going to be aggregation. So in this case, since Flag Illustrator handles the life cycle of UJ emoji, um, as long as Flag Illustrator exists and as long as it's still alive, UJ emoji is also alive. When Flag Illustrator dies, UJ emoji dies. So this kind of relationship is composition. But then if maybe UJ emoji can exist without Flag Illustrator, that was going to be aggregation. So the relationship here was going to be the diamond was going to be unshaded. So it's going to be a white diamond. So yeah, hope that's clear. Then to ppm, so what we're going to do here is we're going to delegate. So we here want to convert a So we want a functionality to convert our grid to ppm. So we don't need to write the function here ourselves. So we have a UJ emoji which has that functionality. So we can just delegate that functionality to our UJ emoji. So this is how we're going to do it. So we're going to say return, then we're going to delegate the functionality to our UJ emoji. So this is going to be dot. So it's going to be emoji pointer. Then I'm gonna call the to ppm function of our UJ image. So we don't really need to write the functionality ourselves, because UJ emoji has that functionality. So we're just going to delegate this functionality to ppm to ppm of our emoji, our UJ emoji. So yeah, that's delegation. That's delegation here. What we're doing here. That's delegation. Then finally, we have illustrate. So our illustrate, it what's this? It needs to accept a flag. A flag is an enumeration. So and that type of flag is going to draw that flag, whether depending on what it is passed here. So the functionality belongs to the UJ image. So here we're also gonna do delegation. So when I say emoji, then we're gonna delegate this functionality to the UJ emoji. So our UJ emoji, the name of the function is not illustrate. In this case, it is draw flag. So it's draw flag. So emoji dot draw flag. Then we're gonna pass in the flag. And yeah, that's it. That's it for our Flag Illustrator. Any question? So I'm gonna compile it and check if there are no errors before we move on to our main.cpp. Okay, we have a few errors. Line 33, emoji is equals to new UJ emoji. Object, no matching function for call. Okay. Let me check what's going on. So I think I know what the problem is. So they're saying, so this line, they're saying there's no, this function, this constructor does not exist. So remember, oh, it makes sense. It makes sense. So here we're passing an object, but then that object is Flag Illustrator. But then UJ emoji copy constructor does not accept a Flag Illustrator. It accepts a UJ emoji, not a Flag Illustrator. So this is wrong. So yeah, how we're gonna do it. So remember, so object has its own emoji. So here we have to pass in this emoji. So our UJ emoji here. So this is how we're gonna pass it. I'm actually not sure how to pass it. We're gonna have object dot emoji. So the emoji is a pointer, and here we're not expecting a pointer. So I think you have to dereference it. I think so. Let's just test it out. I think it's supposed to be something like this. If it's not, I'm gonna have to cancel it. And yeah, that was the error. That was fast. So there are no longer any errors. Any question on this? So yeah, UJ emoji. Remember, this is this we're trying to call the copy constructor, but then the copy constructor of our UJ emoji accepts a UJ emoji object. So at the start I passed a Flag Illustrator object and not a UJ emoji object. That's why we had that error. So now I was correcting it and passing in the actual UJ emoji object. But then remember, this is a pointer. So you have to dereference it. So that's why I included this pointer, this pointer before this. So yeah. Any question before we head over to main.cpp? Everything clear? I hope you're not sleeping. Okay. So there are no questions. So we're going to go to our main.cpp. So in our main.cpp, we're going to include our modules. We have a UJ module and we have a Flag Illustrator module. Then I'm going to include all my namespaces, UJ space and Flag Illustrator. So what we're going to do here, we're going to create a Flag Illustrator object. Flag Illustrator, and I'm just going to call it Illustrator. And I'm just going to use the default constructor. Then let's draw a flag. So Illustrator, so we have our illustrate flag function. This one. Let me call it illustrate flag. This function. So we have illustrate flag. Okay, even before that, let's test out the ppm function. So Illustrator, this is gonna be cout illustrator dot to ppm. So yeah, let's test it out. Okay. Okay, this thing is blocking my bash file from running. Got what? Okay, so let's check out our picture. So this is our 2 ppm. So at the moment we haven't drawn any flag. We're just gonna have a background color here. So this is green. So this is the default background color. So so we use the default constructor. So the default constructor, this is the one. So we just have these. We just have the background color set to this color. Okay, so that's why we are seeing that green color. So it's this one. So now let's actually draw a flag. So illustrator dot illustrate flag. So remember we have to pass in the type of flag you want to draw. So remember we're going to use our enumeration. So let's start by drawing the Japan flag. Let's run that, compile and run that. Hopefully it works. Okay, no errors. So we're expecting a Japan flag. And yeah, so this is our Japan flag. Let's test out the other flags as well. So we have Nigeria. Okay, this is a successful session, I guess, if they all work. Okay, output. Expecting a Nigerian flag. And yeah, that's our Nigerian flag. Let's test out the France flag. France. We're just testing here. I'm sure they all work. Compiling, running, image created successfully. So expecting a France flag. And wait, this is wrong. Yeah, this is wrong. So we're expecting a France flag. So let's see what happened. So, but it doesn't really matter. It doesn't really matter. So let's just test what happened. So the France flag was supposed to fill everything with white, then draw a blue stripe. So we said 0 rows, then 0, calls divided by rows, then we have 0, 85, 165, 164, then draw, then you don't need to draw the white thingy. So we have draw card, we have 0, then rows, then okay, rows. So we have 0, then rows, then we're supposed to have 2 times calls divided by 3. Then we have to have calls divided by 3. Then we have this 2396553. Okay, hope now it's gonna create the correct France flag. Hopefully. But fingers crossed. Then yeah, that's our France flag. So yeah, so for today's session, hopefully you have to understand composition, delegation, life cycle management, and yeah. So that these were the main focus of today's session. So is there any question on that? Any question? And yeah, and that's how we do the thing, the UML diagram composition. Any question on today's practical? Yeah, any 10.
When are we doing inheritance? Because today we were taught inheritance.
But yeah, for in next week's practical, we'll do inheritance. So today we're just focusing on composition. So in the next session, we're going to focus on inheritance and other stuff. So any other questions? So I was asked to do like an example. I don't know if we have time. An example of uh, so a UML diagram from semester test 1. So if you're given a case study like this and they said use this case study to draw a UML diagram, they asked me to show you how to do it. But then before I do that, any question? And are you guys, do you guys have time? So okay, we actually we'll end the session at 10 o'clock. I think this is going to be fast. Any question before I do that UML diagram? So where are we dividing by 2? Oh, that's the previous question. Are you still typing, Koza? Or your question got answered? So yeah, so for your session, for your practical, remember, so instead of drawing flags, you have to draw shapes, which is gonna be very simple. Very, very simple. So yeah. So here you're just gonna have draw circle, draw quad, and you're gonna have a draw rectangle. So so I wanted to ask if to change the output, I wanted to ask if to change the output, do we always have to edit the main? Yes, it depends on what change you're trying to make. So then yeah, you have to edit the main. If I understand what type of output you are trying to change, but then yeah, you have to edit the main. So yeah. Come on here, bro. Are you guys not using your mics? Can we use a switch case in the main to choose which flag to compile? No, we can't. No, we can't. You just pass the flag which you want to do. So here in the UJ emoji, so where you are doing where you are drawing the flags. So here this is where you can use the switch statement, not in main. This is where you can use switch instead of the else if statements. So in main, I don't see a reason why you will use a switch case in main. Yeah, they will edit. They will edit the thing. So we're just gonna so let's say I want to test if your cycle is working correctly. I'm just gonna pass my enumeration here, cycle, then run it, pass my square. Yeah, this is what we're going to do. Yeah. Yes. Like why are you guys like where are you going to use a switch case here? That doesn't make sense. Or you mean unless if you mean this side, this is why it makes sense to use an if statement instead of a switch case, not here. I get you can't draw two flags all at once. If there are no further questions, let's try this thing. Let me split my screen. Oh, well, let me delete this. So we have a scenario here. They're saying a vehicle has a set of floating point attributes denoting its mileage and price. It also has a color which is represented by a color record structure. Okay. The mileage, price, and color must be set using a constructor. Only the price must be modified after creation. So let's just read the whole thing. A solar car is a vehicle and has an integer attribute representing the number of doors. It can lock its doors, an operation that does not return a value. Okay. A motor vehicle, a motorcycle is a vehicle. So you're saying so. But okay, I'll explain as I move on. A motorcycle is a vehicle that has a floating point attribute representing fuel remaining. It can compute the remaining kilometers and return the value as an integer. Okay, so both solar car and motorcycle must provide the same creation option as vehicle. Okay, a dealership has a name, location, and rating, which are all string attributes. The attributes must be set using a constructor and only accessible thereafter. These are very important statements. So a dealership also maintains a collection of vehicles whose elements must be both accessible and modifiable as in appropriate. Vehicles are not created when a dealership opens. In addition, vehicles are not destroyed when a dealership closes down. So okay, so we're gonna break this thing into parts. So we're gonna start with the first paragraph. Okay. Let me So yeah, let's start. So they're saying, so we're drawing a UML diagram. Nah. So do we just write our names on draw? I will show you. I will show you how to do it. So they're saying a vehicle has a set of floating points. So a vehicle is a class, and they're saying it has a set of floating points attributes denoting its mileage and price. What does this mean? So this means that we have a class called vehicle, and it has the following attributes or parameters, not parameters, data members, which is mileage and price, and they're both of type float. Let's do that first. So we have, let me do this. We have a vehicle, then we have mileage, then we have price. So we're gonna do it step by step. So we have a vehicle, and we have, let me increase these things. Then we have mileage. I hope this is visible. I feel like it's small. Let me do this. We have mileage, which is of type float. Then we have another variable. I think it's price. Yeah, it's price, also of type float. Okay, let's continue. It also has a color, which is represented by a color record structure. So it also has a color. So color is a record structure. So let's do that. Oh, remember these are private. Remember these are private. So they're saying we also have color, and the type of color, it's a record structure. Let's assume it's RGB color. Okay. Color, which is represented by a color record structure. Oh, the name of the record structure is color. So as you can see, it's color. So let me change this to color, not RGB color. So the name of the record structure is color, and the name of the variable is color of type color, if keep the letter C. Then the mileage, price, and color must be set using a constructor. So they're giving us information. So basically, they're telling us we need to have a constructor with parameters. Remember, I told you from last week that a constructors are special functions used to initialize data members. So here they're saying that we're going to use a constructor to initialize these data members. Okay. So let's write our constructors. So we have a default constructor. Vehicle does not have any parameters, and it does not return anything. It's a constructor. Then we have our constructor with parameters, vehicle. So remember that I said we have to set these things using our constructor, meaning we have to have a constructor with parameters to initialize this data, mileage, price, and color. So yeah, so let's pass in our parameters, mileage. So remember that you can set them as, you can have it have a capital M, but then it's fine. You can you can write them the same. So we have mileage of type float. Let me make a space over here. Then our second parameter, we have price, which is of type float. Then finally we have color, which is of type capital letter color, which is a record structure. And our constructor doesn't return anything. Okay, so they're saying only the price must be modifiable after creation. What do they mean? So remember, these are private. These are private. Né? So if they are private, let me make an example with our thing here. So we have emoji. Emoji is private. So meaning we can modify emoji outside the class. We can come here and say, we can say Illustrator dot emoji, however it's written, emoji, emoji is close to maybe something else. Let me write some random word. So we can be able to modify emoji outside the class. Why? Because emoji is private. So how do we modify it if it's private? So we modify it using the getters and setters. So this is what they mean. But then they're only saying price must be modifiable after creation, meaning price is the only one which has a getter. So mileage and color don't have getters. So I'm only gonna have I'm gonna have a getter for our price. No, actually this is not a getter. This is a setter. So we have to, a setter, remember a setter is a mutator. A mutator is used to modify data. So this is not, this is not a getter, is a setter. So we're gonna have set, set price. Wait, did they set price? Yeah, set price. So remember we have to pass in a price. So I'm gonna pass in price of type float. Remember setters don't have a return type. The void functions. So this is our setter for our price. So this is what they mean when they say only the price must be modifiable after creation. Then so automatically you have to create the getters for all of your variables. So they didn't mention it, but then you have to create the getters for all your variables. So we're going to have get mileage. Get mileage. So mileage is a float. It means this function is going to return. It's going to have a return type of float. Then we have get price. So price is a float. Then we have get color. Get color. Color is of type color. So yeah. So guys, if let's say they don't mention this statement, you always have to include your getters and setters. Like it's a must. You have to include them to get full marks. Then if maybe they say a certain variable like this it only has to be modifiable, then that's when you know you only need a setter for a certain variable. But then if they don't mention anything, you have to know that you have to include all the getters and setters always. So that's our vehicle. That's our vehicle class. It has everything. The getters and setters. Remember, you also have to add. So to get full marks, you also have to add the copy constructor and the deconstructor. Let me add them. Object. Okay, we don't have time. I'm gonna have object. Also gonna have our deconstructor. Yeah, you have to add everything to get full marks. Then yeah, that's it for our first thingy. Then we're going to go to our second paragraph. So they're saying a solar car is a vehicle. This is very important. They're saying a solar car is a vehicle. This is a type of relationship. As you mentioned, you learned this in class today. That kind of relationship is inheritance. So when they say a solar car is, so when they say something is something, it means it's inheritance. So this is a type of relationship which is inheritance. So meaning solar vehicle is going to inherit from, SolarCar is going to inherit from vehicle. So yeah, keep note of this. A solar vehicle is a vehicle. So yeah, let's create our solar vehicle and show the relationship. So that's our thingy. So this is our solar car. So to show inheritance, you remember you have to use that line with a triangle. Let me look for it. No, not this one. Yes, this one. So let me remove this extends. So in Java, we don't say inheritance, we say it extends. That's why you saw extends there. So this is how you do it. So SolarCar inherits from vehicle. So meaning this thing has to point to, this is going to point to SolarCar. Let me do this. This. So let me do this. Yeah, let me do that. So a SolarCar is a vehicle. So that's inheritance. You have to draw this line. Yeah, anyway, let's continue. Okay, and a SolarCar has an integer attribute representing the number of doors. So we have an attribute here representing the number of doors. So I don't know, we can call it number of doors. So it's an integer. I can just say int. Okay, so has an integer attribute representing the number of doors, and they're saying it can log its doors, an operation that does not return a value. So when they say it can log its doors, an operation that does not return a value. So here they're specifying what type of functionality this class have. So SolarCar has a function, has a functionality of locking its doors. So we need to add that functionality over there. So anyway, so we also have to add our constructors. So don't forget to do that. And blah blah blah. Constructor with parameters. Yeah, I have to add all the constructors, otherwise. Okay. Okay, then for our copy constructor, we're gonna have these parameters. Remember when they say something is something, it inherits. Remember, is going to have, let me do this. So remember, a SolarCar is a vehicle. So everything that a vehicle has, a SolarCar is going to also have them. So meaning SolarCar also have the attributes, mileage, price, and color. So we have to set them. How do we set them? I'm going to use a constructor. So yeah, you will learn more next week on this. So finally we have a deconstructor. Sorry, SolarCar. SolarCar. Let me change this to lowercase. And bold. I don't know what's the opposite of bold. Okay. Oh yeah. So they said we have the SolarCar is a function to log its doors. So let's add that function operation. So you can just call it log doors. Doesn't matter. Then let's see if they specified the return type. So they say an operation that does not return a value. What's an operation that does not return a value? That's a void. That's a void function, meaning log doors is a void function. Let's go to our next thingy. So we're saying a motorcycle is a vehicle. So that's also inheritance. Let's do that. So let me copy and paste. Let me do this for a moment. Let me move everything to the side. Okay. Let me copy and paste this line. So this is also inheritance. Ash. Let me delete this and let me look for my, oh, that's my extents. Okay, so yeah, let me remove the extents so that I don't confuse you. So now we have, what's that? A motorcycle, which is also a vehicle. That's why we showed the inheritance. We showed the relationship over there. So let me save time and do this. So this is going to be motorcycle. It's going to be motorcycle, motorcycle, or deconstructor, motorcycle. Let me delete this functionality. We don't have parent. Oh, shush. And yeah, so let's see what our motorcycle has. So a motorcycle is a vehicle and is a floating point attribute representing fuel remaining. So we have fuel remaining. Fuel. So I'm just gonna call it fuel. Then this is a type float. Oh, so we forgot something here. So we have to have our getters and setters for the number of doors. So get num doors. So this is int, then set num doors. I'm gonna pass in our num doors, type int, then this is a void function. This is a getter, it's a void function. So yeah, if so, we'll see what they say. If we really need these getters and setters, if they say something we don't have, if they say we don't have to include them, we will see. Then for our fuel, let's read and check if we need them. So it can compute the remaining kilometers and return the value as an integer. So this is the functionality. It can compute the remaining kilometers and return the value as an integer. So again, we have the fuel remaining. So I think this function that computes the kilometers is going to calculate the number of kilometers using the fuel remaining. So let's add that functionality. You can call it anything. Let me just say compute KL. They didn't say anything. Let's see. So it returns the value as an integer. So it returns an integer. Okay. So you can just call it compute KL. So for now, let me add the getters and setters as well for the fuel. So we have get fuel, doesn't accept anything. It's a float. And we have set fuel. We accept fuel of type float. This is a void function. Okay. Yeah. So yeah, let's see here. So they're saying both SolarCar and motorcycle must provide the same creation object as vehicle. Same creation object option as vehicle. So I think they're talking about this thing, the constructors, same creation options as vehicle. So these are our constructors, our creation, what is this? Creation functions. Yeah. So I think we already did that. So we see we have our constructors are similar. So that's fine. Let's move to the next point. And then that's the last paragraph. So we have a dealership. So they're saying a dealership has a name. So meaning, so a dealership is now a separate class. So no inheritance whatsoever. So let me put it here. So we have a dealership. So they're saying a dealership has a name, location, and rating, which all are string attributes. Okay, let's add them: name, location, and rating. 1, 2, 3, which are all strings. So these are private. Name, which is a string. Location, which is a string. Then we have, what's the other thing? Our rating, which is a string. Okay, so remember here, as always, you need to have the constructors. So without wasting time, let me add the constructors. Oh, let me do this. Fold. These are my constructors. Copy constructor, deconstructor. For the copy constructor, let me say object of type that. Okay, then yeah, we have, obviously you need to have the setters and getters. I think we get the point. I mean, a dealership has a name, blah blah blah. All the attributes must be set using a constructor and only accessible thereafter. So let's see this point. They're saying only accessible thereafter. Meaning, so this means we only have to be able to access the variables, but not modify them. What does that mean? That means we only need getters and not setters. So that's what that means. So I think you already understand this line. So all attributes must be set using a constructor. So meaning, so in our, you have to have a constructor here passing all these variables. So name, string, location, that's a string, rating, that's a string. Then we only need getters. So as they said here, they said only accessible thereafter. So meaning we only should be able to access these variables, but not modify them. So if they didn't tell you that it's a must, you were supposed to add all the setters and getters. So now they told you only add the getters. So by this statement here, only accessible thereafter. So it means you only have to have the getters. So let's have get name first. So there's a string. Then get location. There's a string. Then get rating. That returns a string. Then what else do we have? A dealership also maintains a collection of vehicles. Ooh, did you see what they said? A dealership also maintains a collection of vehicles whose elements must be both accessible and modifiable as is appropriate. So meaning, so they're saying a collection. So this is composition, but then now they're saying a collection. So meaning this is a list of vehicles. So let's add that list. So a list of vehicles can mean many things. So in our instance, let's take this as an array. We have vehicles. So this is an array of vehicle. Okay, then they're saying, so this is an array. So they're saying whose elements must be both accessible and modifiable as appropriate. What does that mean? So this is it's an array. We have to be able to modify each vehicle in this array. So from our vehicle, we only have get color, get price, get mileage, set price. So that's fine. We can use these functions to modify our vehicles. I don't know if there's something which I'm missing. I don't think so. So this point where they say whose elements must be accessible, modifiable as appropriate. I don't think there's anything we have to add because we just say vehicle at index 0 dot get price if we want to change something. So at the moment, I don't see any function which we can add to our dealership. But anyway, before I forget, this is a type of a relationship. So they're saying it maintains a collection of vehicles. So I assume this is a. So let me read further and check. Vehicles are not created. Oh, they're saying vehicles are not created when dealership opens. You remember when I said its composition? If I said its composition, if maybe uh, the class can still exist without the other class. Then here they're saying vehicles are not created when a dealership opens. So in addition, vehicles are not destroyed when a dealership closes down. Sorry. Vehicles are not created. So I think, so before I head over to that line of code, so remember vehicle. So I think we need to have, so let's have a function here to create vehicles. Vehicles. So I assume we need to like we need a number of vehicles. I guess this is a dealership. No. So yeah, that line actually makes sense. This line makes sense. So they're saying a dealership also maintains the collection of vehicles whose elements must be accessible and modifiable as appropriate. So we need to have a function to add a vehicle to our list of vehicles and a function um, to remove a vehicle from our list of vehicles. So let's add those functions. So this thing you just have to think about it logically. So this is a dealership. What they're saying, a dealership has vehicles. Obviously, they have types of vehicles, obviously. So we need to know the number of vehicles. We need to be able to add a vehicle to our dealership, and we also need to remove a vehicle to our list of from our dealership. Let's say when someone buys a car, so obviously we need to have a function that removes uh, that vehicle from our list. So sometimes you need to think about this logical. So let me add those functions. So let's have add vehicle. Then we're just gonna pass in a vehicle. So that can be a void. Then let's have remove vehicle. Let me just pass an index. So index a vehicle is of type. We're returning a vehicle. So yeah, let's also add a function like to create. I can remember this is a So let's say this is an array. So if it was a pointer, we also need the number of vehicles, for example. So either you can add the number of vehicles in your constructor. So as long as you show where you are creating this thing. But then I say this point, it says vehicles are not created when a dealership opens. So if vehicles are not created when a dealership opens, maybe it means we shouldn't add the number of vehicles in our constructor. Again, we call our constructor when we create our dealership, so we don't need to add our thingy there. So our add vehicle, if the list is it's 0, then automatically it will add the list. Like let's say the list, let's say it was a pointer and the memory was not allocated, for example, then we say add vehicle. So the function will allocate memory automatically. So let's assume that. So now, let's get to this point. So they're saying vehicles are not created when a dealership opens. So that's the constructor thingy. So in addition, vehicles are not destroyed when dealership closes down. Remember when I said the difference between composition and aggregation? So I said composition is when I get it's a obviously first of all it's a class inside of another class, but then the class that contains that other class, let's say that class handles the life cycle of the other class, that's going to be composition. But then, so remember that other class cannot exist. It only exists if this class containing it exists. So if this class dies, that class also dies, meaning it gets destroyed. But then if that class, let's say, so then if let's make an example with dealership. So vehicle is inside dealership. Nah. So if vehicle still exists even after dealership is destroyed, that's going to be aggregation. But then if dealership handles the life cycle of vehicle, that was going to be composition. So yeah. So what they're telling us here, they're basically telling us this is the relationship here is not composition, it's aggregation. That's because vehicles are not destroyed when a dealership closes down, meaning a vehicle will still exist without the existence of a dealership. So meaning this relationship here is aggregation, not composition. I hope you get that. So let's show the thing here. So remember I said aggregation, it is a diamond, but then an unshaded diamond. This one. Let me yes. Then yeah, that's our relationship. And that's the end of our thingy. Any questions? Any questions? I hope that's clear. And yeah, I hope you noted down the difference between composition and aggregation, because they can be confusing. And these are going to be asked also in your semester test. So yeah, so if you want to know if the contained class is a pointer or not, so remember if vehicles was a pointer, if this vehicles was a pointer, it means after dealership gets destroyed, it means we have to deallocate memory and destroy the vehicles. That's when you will know that vehicle is supposed to be a pointer. But then if they say here they're saying vehicles are not destroyed, it means vehicles is not supposed to be a pointer. That's how you check these things. Any question? So let me stop the recording. Oh, then yeah. So let me show you how you save this thing. So you're going to go to file, export as PNG. Export, I'm gonna store it in download, then I'm gonna give it a name, random name. Let me just call it design, for example, and download. Then afterwards, I have to create a Word document. So design